Let's talk skyscrapers, the marvels that define a city's skyline and stretch the limits of engineering. Building tall isn't just about stacking floors, it's the art and science of reaching for the sky, one level at a time. The first rule: it must stand up, no matter what nature throws at it. Gravity is relentless, always pulling down, so you need a core made of concrete and steel, materials chosen for their incredible strength and durability. This core, usually right in the center, acts as the backbone, supporting everything from the floors you walk on to the glass windows that let in the light. But gravity isn't the only challenge. There's also wind. At great heights, wind can make buildings sway dramatically. So engineers shape towers to be aerodynamic, slicing through gusts instead of fighting them. Sometimes, they even add giant pendulums, called tuned mass dampers, hidden inside the building, swinging gently to counteract the wind and keep everything steady. In earthquake zones, the challenge is different. Buildings must flex and absorb shock, not crack or collapse. That's why the connections between beams and columns are designed to bend, like a tree, swaying in a storm, so the building can move safely with the earth. And it all rests on a foundation that's immense, reaching deep underground, anchoring the entire structure to solid rock, so it won't tip or sink. Every part, from the steel skeleton to the concrete base, is a careful balance of strength and flexibility, engineered to handle whatever comes its way. Building a normal skyscraper is already a complex feat, involving thousands of workers, years of planning, and endless calculations. And that's before you even try anything truly wild, like twisting shapes, sky gardens, or gravity-defying bridges. But in Singapore, engineers and architects were about to attempt something that would push the boundaries of skyscraper design even further. In the early 2000s, Singapore was thriving, but its leaders wanted more. They saw Marina Bay, a patch of water, as the future heart of the city. The vision, a vibrant 24/7 waterfront for living, working, and playing. They wanted an icon, a landmark as bold as the Eiffel Tower or Sydney Opera House. The plan? An integrated resort hotel, convention center, shops, restaurants, and a casino to fund it all. But it had to be spectacular, architecturally and culturally. An international competition was launched, seeking a design that would redefine Singapore's skyline. The brief: create a destination, not just a building. The result needed to be extraordinary, something the world had never seen. And the winning design was exactly that. Singapore was ready to make a statement. The winning architect, Moshe Safdie, didn't do boring. Known for his daring ideas and bold visions, Safdie was never one to settle for the ordinary. When he was handed the opportunity to design something truly iconic, he saw it as a chance to push the boundaries of architecture and imagination. Inspired by decks of cards, he imagined 3 curving hotel towers, leaning and rising together. Each tower would be a unique shape, as if frozen mid-fall, creating a sense of movement and playfulness that had never been seen in a city skyline before. But the real twist? A massive sky park connecting all 3 towers at the top. This wasn't just a simple bridge, it was a bold stroke of genius, a structure that would redefine what a rooftop could be. This wasn't just a bridge, it was a 340-meter-long garden, with jogging paths, restaurants, and a pool nearly 200 meters in the air. Imagine strolling through lush greenery, dining with panoramic views, or swimming above the clouds, all on top of a skyscraper. The sky park would cantilever 67 meters over the edge, longer than the Eiffel Tower is tall. This dramatic overhang would become an instant icon, a feat of engineering that seemed to defy gravity itself. The towers themselves leaned up to 26 degrees, far more than Pisa's famous tower. Their dramatic angles weren't just for show, they created a dynamic silhouette and challenged every conventional rule of skyscraper design. The design was sculpture on a city scale, blending nature and technology. It was a vision of the future, where urban life and green spaces could coexist in harmony, high above the bustling streets below. On paper, it was stunning. In reality, it was a monumental engineering challenge. Every line on the blueprint represented a problem to solve, a risk to manage, and a dream to realize. Engineers faced 3 leaning 55-story towers, and a 7,000-ton park to balance on top. The logistics were mind-boggling. How do you build something so heavy, so high, and so precariously balanced? The vision was brilliant, but building it would push the limits of what's possible. Every step forward meant inventing new techniques, new materials, and new ways of thinking about construction. The world had never seen anything like it. This was more than a building. It was a statement, a symbol of ambition and creativity on a global stage. The question, could it actually be built? Could the laws of physics and the limits of engineering be bent to make this dream a reality? The answer would require some of the boldest engineering ever attempted. It would take vision, courage, and a willingness to risk everything for the sake of creating something truly extraordinary. Building a leaning tower defies construction instincts. Normally, weight pushes straight down, but these towers curved outward, creating huge tension. The straight western wall acted as a spine, resisting the pull from the leaning side. Engineers used heavily reinforced concrete to handle the strain. Construction was tricky. The straight side went up first, then the curved side was built off it, floor by floor. The building was unbalanced during construction, so computer models predicted every stress and movement. At the 23rd floor, towers 1 and 2 joined at a central atrium, bracing each other for stability. This connection had to be perfect. Any error at the base would be magnified at the top. Precision was everything. The margin for error was nearly zero. Every step was a high-wire act in engineering. The solution, relentless calculation and control. Before building up, engineers had to solve the problem below. Marina Bay is reclaimed land, soft, silty, and unstable. To anchor the towers, they drilled over 5,000 massive piles deep into the earth, some reaching 50 meters to bedrock. These piles acted like stilts, transferring the weight safely down. On top, a thick concrete raft foundation spread the load across all the piles. This raft also had to resist the unique forces from the leaning towers, holding them together at the base. The underground work was immense, an invisible feat of engineering. Without it, the towers would have slowly sunk into the bay. Only after this hidden foundation was complete could the real spectacle begin above ground. The stability of the entire project depended on what lay beneath. Every skyscraper needs a strong base, but this one needed a miracle underground, and they pulled it off. With the foundation set, construction soared skyward, but precision was critical. The towers had to align perfectly for the sky park to fit. Engineers used pre-cambering, deliberately building the towers slightly off course, knowing they'd settle into place. Over 700 sensors tracked every movement, feeding data to a central control room. GPS and lasers monitored positions to the millimeter. If a tower drifted, adjustments were made on the fly. Temporary steel struts and jacks supported the leaning faces until the concrete was strong enough. Each floor was cast with meticulous care. A game of inches played 55 stories up. The process was slow, painstaking, and relentless. The entire project depended on this precision. One misstep, and the sky park would never fit. While the towers steadily rose higher, the sky park itself was being constructed in a different way. Down on the ground, in 14 enormous steel segments. Each segment was carefully assembled by teams of workers who pieced together massive steel components with precision and care, knowing that soon these pieces would be hoisted to dizzying heights. Each segment was a true giant, weighing up to 700 tons, far too heavy for any ordinary crane to lift. The sheer scale of these pieces was staggering, and moving them would require a feat of engineering in itself. To solve this, engineers turned to strand jacks, powerful hydraulic devices that could slowly and steadily hoist each segment up the towers, much like a giant fishing reel winding in a massive catch. This method allowed for precise control, but demanded patience and nerves of steel. The lifting process was slow, tense, and fraught with risk. Every movement was carefully monitored, and the weather was watched constantly. High winds or storms could halt work in an instant, adding to the suspense. Once each segment reached its final position, teams of workers welded and bolted them together high above the city, gradually forming the sky park's strong, continuous spine. Every connection had to be perfect, as the entire structure depended on their strength. The most daring part was the dramatic 67-meter cantilever, which jutted out boldly from the towers. This overhanging section was the final piece to be installed, and it pushed the limits of what was possible in steel construction. But the towers themselves were not rigid. They could move up to half a meter in strong winds, or under the intense heat of the sun. This constant motion posed a huge challenge for the engineers. To prevent the sky park from being torn apart by these movements, engineers installed massive bearings and expansion joints beneath the structure. These components acted like shock absorbers, allowing the park to move safely with the towers. Thanks to these ingenious solutions, the towers could sway independently, while the sky park above remained perfectly intact, bridging the gaps between them like a flexible ribbon of steel. The entire structure was designed to flex and breathe, adapting to the forces of nature. It was a marvel of engineering, turning a rigid steel frame into something almost alive. Piece by piece, the ship was lifted into the sky, each segment joining the next until the vision was complete. It was a process that required not just strength but also creativity and teamwork. The result was breathtaking. A floating park, high above the city, seemingly defying gravity and logic, and offering a new perspective on what buildings could be. In the end, it was a true masterclass in heavy engineering, a testament to human ingenuity and the power of imagination. With the sky park in place, Marina Bay Sands was complete. It wasn't just a hotel or casino, it was a feat of ambition and engineering. Every challenge, from soft ground to leaning towers, was solved with innovation. Real-time sensors, GPS, and strand jacks set new standards in construction. Today, its silhouette is instantly recognizable worldwide. It's the centerpiece of Singapore's skyline, drawing millions of visitors. More than steel and concrete, it's a symbol of daring to think differently. Marina Bay Sands proves that audacious dreams